Okay, I think we are ready to get started. So welcome everyone to today's CNCF webinar. Edge computing, it's not just about a bunch of small clouds. My name is Sanjeev Rampal. I'm a principal engineer in the container platform engineering team at Cisco. And thank you for joining. We'd like to welcome our presenters, Satish Salagame and Nick Chase from Mirantis. The topic is edge computing. And as you know, that's an interesting area that looks at distributed cloud deployments. And we're really looking forward to hearing from Satish. During the webinar, you will not be able to talk as an attendee. So please look for the QA box and drop your questions in there. And we'll get to as many as we can at the end. The session is being recorded and will be links will be sent out afterwards to both the recording and the presentation. With that, I'm going to hand it to Satish and Nick to introduce themselves and go ahead with the presentation. Satish and Nick, go ahead.
All right. So good morning, everyone, or whatever time it is where you are. I am Nick Chase from Mirantis, as Sanjeev said. I'm here to introduce Satish Salagame. Again, he is our Director of Engineering and Networking here at Mirantis. His background is in networking and design and all kinds of things that really set him in good stead for being responsible for edge cloud solutions. So good morning, Satish. It's good to have you here.
Thank you very much, Nick, for the introduction. Hello, everyone, and thank you very much for joining this webinar today. So let's go ahead and look at the agenda for today. So we are going to get started with edge computing, talk about what edge computing is and why it matters. We look at a few important use cases that are critical for edge computing. We look at key benefits that we can get from edge computing. And based on that, take a look at what are some of the key infrastructure requirements to make this happen. And then we get into more interesting topics like how does Kubernetes fit into the edge architecture, and more importantly, if we have VM-based VNFs, this is the NFV world. If we have VM-based VNFs in a Kubernetes edge, what are some of the challenges and what kind of interesting solutions exist in that area? That's in a nutshell the agenda for today.
All right. So let's kind of start off with the basic question, which is, what the heck is this edge thing and why do we hear so much about it? Why do we care about this?
Yeah, that's a good way to start, Nick. So there are actually multiple ways to look at edge computing. So let's, from a pure infrastructure-centric point of view, edge computing is essentially cloud principles applied at the network edge close to the user. So when I say that, it includes compute virtualization, storage virtualization, networking virtualization, resources on demand, API-driven approach, automated lifecycle management, and use of commodity hardware. So essentially, these are some of the powerful cloud principles that make the network edge highly flexible and programmable. Now, if we look at the edge computing from a network operator point of view, it's really the convergence of IT and telecom networking. As you can see in this picture that I'm showing, we can have a variety of devices like mobile phones, IoT sensors, connected cars, all of them connecting to access networks using different access methods. It could be radio access network, Wi-Fi, cable, or fiber. So then you have the aggregation network, the regional POP, and the core cloud. Depending on the use case, the edge cloud can reside in any of these networking layers. So this really allows network operators to open up their networks and open them up for new business opportunities and value chains that just did not exist before. Now, finally, if we look at edge computing from an application-centric point of view, it's really all about new, innovative, and immersive edge applications. This is really a great opportunity for app developers to create applications that are tailored to local conditions, applications that provide highly contextualized services. And moreover, these applications can have low latency and high bandwidth guarantees because of the proximity of the edge cloud to the user. Not just that, also the way the edge infrastructure is designed. Eventually these innovative edge applications are the ones that are most likely going to have a very significant impact on the overall success of edge computing.
All right, so those are the kinds of things, but give us some examples of specific use cases.
Right, so let's talk about edge use cases. At a high level, when you look at edge computing use cases, they really fall into two big buckets. So the first one is the third-party edge applications. These are actually the most interesting ones. So let's look at some of these categories here. Real-time applications. So these are applications that require very low latency and low jitter. This is where augmented reality, virtual reality, connected cars, tactile internet, smart cities, industry 4.0, all these use cases fall into this bucket. Then you have the immersive applications. So these are the ones that require extremely high network throughput. Think about 4K video, 360-degree video. Then the cost reduction. So this is interesting. This is where the applications are trying to save upstream bandwidth and also save processing in the central cloud. Good example is a video surveillance. IoT gateway is another good example here. If we move to the self-contained category, this is where you have the stadium events or concerts or airports. And we are going to talk about network slicing, and that plays a critical role here because essentially each one can be a slice and supporting the specific requirement. The private enterprise is about applications like RAN to radio access network to enterprise breakout CPE type of applications. So that's what is included here. Now, if we look at the other bigger bucket, the other category, which is operator applications, this is where we have applications that are deployed by the operators. Analytics is one category here. This is all about collecting large amounts of data analytics and even running analytics on the edge itself, but then sending small amounts of that data, small batches of that data to the core. Compliance is another interesting category here. It includes copyright information or geographical data placement. Copyright enforcement is also interesting here. Let's say you are sitting in a concert or in a sport event. What edge application can do is it can disable upstream transmission of that copyright data, or it could even reduce the resolution if required. I mean, those kind of things are possible. Edge applications can also also enforce data to reside in a specific geography. Security is about moving the security perimeter very close to the source. So this way we can block security threats at the edge itself and protect the core network. And finally, the NFV category. This is actually a very important category here because edge is ideal for running different types of VNFs. Take, for example, access VNFs. VNFs like virtual RAN, virtual CMTS for cable, virtual OLT, CRAN. If we talk about security VNFs, virtual firewall, IDS, IPS, unified trust management, content filtering type of VNFs. And for service enhancement VNFs, we are talking about virtual DPI, WAN acceleration. So, NFV workloads are also going to be important use cases for the edge cloud.
All right, excellent. So this is some of the things that we can do with it, but what is it about edge computing that enables these use cases?
Right. So um, there are a lot of things about edge computing. In fact, when we talk about all these things, uh, there are key benefits that the edge computing gives you, and that kind of enable all these use cases. I already talked about some of these in the previous use cases, but let's go through this. Ultra low latency. This is an extremely important benefit that you get from an edge cloud. Typically latency in milliseconds, and this is significantly lower compared to what you get from a centralized data center. Again, the main reason here is because of the proximity to the user, but then again, the way the infrastructure is designed also matters. High network throughput, because content is either locally generated or cached here. Context awareness is another great benefit here, because the edge cloud has access to the radio network, and the information that is provided by the radio access network can now be efficiently used by the edge applications. We talked about data filtering, data reduction in the previous slide, compliance again, and security. So these are some of the great benefits that the edge computing gives us.
Okay, so those are the benefits. Now, there's a lot of buzzwords in here, and one buzzword that keeps coming up a lot whenever we're talking about edge computing, at some point somebody is going to say something about 5G, and somebody's going to say something about network slicing. You yourself have said it in this conversation. What is network slicing? What does all this have to do with that?
Right. So let's talk about network slicing. So what is network slicing, and in a more general sense, how these technologies, Nick, as you said, how does network slicing, 5G, SDN, NFV, all these come together, right? So network slicing is a form of virtualization that allows multiple virtual networks, or let me say multiple logical networks, to run on top of a shared physical network infrastructure. So using network slicing, what network operators can do is they can partition their network resources, configure each partition, and use each partition, or let's say a slice, to a specific user or a specific application or a specific use case. So with 5G, the networking infrastructure is going to support a very wide variety of application, as we talked about just a minute ago. So we can have IoT, we can have mobile broadband, we can have connected cars, and many, many more use cases. Now, the interesting thing is the networking characteristics and the transmission requirements of these applications are very different. It's quite different from application to application. Let's take an example. When we talk about IoT, there will be very large number of devices, these IoT devices, but each device will probably require low network throughput. On the other hand, when we talk about mobile devices running streaming 4K video or 360-degree video, the network bandwidth requirements are going to be extremely high. But when you think about the number of such devices, it's going to be much lower compared to the IoT sensors and other IoT devices. And with connected cars and self-driving cars, the critical requirement is low latency. So the key goal of network slicing is really to partition the physical network at an end-to-end level. So here we are talking about end-to-end level. That means, all the way from RAN edge to all the way from RAN slice to edge slice to the cloud slice, right? So partition the physical network uh, at an end-to-end level, and allow very optimum grouping of traffic, and more importantly, provide isolation at the slice level itself, right? So by doing this, it really maximizes the flexibility of 5G networks. So because of all this, network slicing is extremely critical for 5G. And this is, again, because of so many different type of use cases 5G promises to support. In fact, we can say that without dynamic network slicing, it's very difficult to achieve the promise of 5G. You often see network slicing being referred to as the secret sauce behind 5G because of this reason. So it's really the combination of SDN NFV, because network slicing actually uses the SDN and NFV concepts heavily. It's the combination of SDN, NFV, edge computing, and network slicing that gives 5G the ability to very efficiently handle all these diverse set of applications in an extremely flexible way. That's how all these things come together.
Okay, so what do we actually need in order to make edge computing work?
Right. So let's talk about what do we need, right? The infrastructure requirements. Again, we have touched upon some of these things, but there are quite a few more interesting things that we can talk about here. Ultra low, that going to demand ultra low latency. A lot of edge applications need this. High network bandwidth. This is another key requirement for especially for highly immersive edge applications. Now, constrained resources. This is interesting. There are a lot of edge infrastructure will have space constraints, power constraints, and cooling constraints. In many cases, there is also need for ruggedized racks to be deployed. And security, there are a lot of security concerns, including physical security of the edge cloud rack itself. It's very important to have flexible infrastructure because we need to iterate and evolve based on new requirements. And from a software flexibility, infrastructure flexibility point of view, SDN, NFV, network slicing, all these things play a big role. And high performance, especially CPU, memory, storage, enhanced platform awareness features, data plane acceleration, all these become important for high, to make sure that there is a good user experience. Now, if we now we are going to have a large number of these geographically distributed remote edge clouds, and therefore distributed. So it's a highly distributed architecture, which means a powerful central common management plane also becomes extremely important. And once again, since we are dealing with hundreds of these clouds, automation is key. We have to have zero-touch provisioning, zero-touch lifecycle management, zero-touch operations, logging, monitoring, alerting. All these things become critical when we are talking about edge infrastructure.
Because we have so many of these clouds and they're all over the world, and you can't
absolutely.
out to them.
Yeah, there is no way you can have anything manual happening in this ecosystem, right? Compatibility is another important requirement, because edge clouds are not going to function in isolation. They need to work with orchestrators. They need to work with MEC application orchestrators, Mono, VNF orchestrators. So how compatible are those with industry standard orchestrators? And so that becomes an important requirement as well. Workload diversity is another important requirement. Ability to support VMs, ability to support containers, and in some cases even workloads. We are going to talk more about VNF workloads. In an edge cloud, it's important to have the ability to support VNF workloads that could be either VM based or even container based, and then different types of MEC applications. Now, small footprint, hardware footprint is also an important infrastructure requirement. In some use cases, it could be as small as just one single node, or 3 to 6 nodes, half rack, full rack, multiple racks. It all depends on the use case.
All right. So that now we've got in our head sort of an idea of what is required from an infrastructure standpoint. This is a CNCF webinar, so of course the big question is, what does this have to do with, say, Kubernetes?
That's a good question, Nick. So let's talk about Kubernetes in edge architecture, right? So yes, Kubernetes is actually well suited for a small footprint edge cloud. This is because, we all know that Kubernetes is easier to manage. Containers have much lower overhead compared to VMs, which means we can have higher density of containers on a per worker node basis. Because of all this, more resources are going to be available for edge applications or edge VNFs, even in a small cloud. So using Kubernetes taints, in fact, we can run workload pods even on the master node if this is required. And this is probably a good option for a really compact edge cloud.
All right.
Now, in terms of the typical data plane acceleration techniques like SRIOV or DPDK and other EPA features, these features also work with Kubernetes pods, so that shouldn't be a problem in designing the infrastructure for low latency and high network throughput using Kubernetes. Right? In the picture that we are showing on this slide, we have a very simplified small Kubernetes edge with 3 worker nodes and running different edge applications like video surveillance, applications like media streaming. So Nick, as long as we are running containerized edge applications and containerized VNF workloads, life is simple, life is good.
Okay, but we've already established that a lot of this is VNF, and VNFs in general are VMs. So how do we handle that?
Right. So there are a lot of challenges. That is true. A lot of challenges in running VNFs in Kubernetes containers. I should say that currently there is quite a bit of effort, quite a bit of work in the industry to make VNFs cloud native and deploy them as containers. But as of now, a large portion of the VNFs still run as VMs. And sadly, in many cases, these VNFs are really virtualized replicas of their hardware appliance, which kind of defeats the whole purpose of the NFV. Now, the picture on the left side here shows the functional view of a VNF as it is described in the HC document. So you can see that the VNF is made up of multiple VNF components. These are the VNFCs, and these run on top of the NFV infrastructure. The EM, which is the element manager for the VNF, essentially manages the functional aspects of the VNF. The VNF manager, the VNFM that you see on the right-hand side, it's actually part of the bigger MANO, or the management and orchestration component, and that manages the general VNF functions. Again, one of the problems is that many VNFs are tightly coupled with specific NFVI and Vim. Say, for example, OpenStack. Lots of them even come with proprietary VNFMs and orchestrators. And because of this, there are a lot of challenges in supporting things like service function chaining of VNFs, especially if we are dealing with VNFs from different vendors.
Okay, so I've gotten completely thrown here for just a second. I am so sorry. Okay, so how do we run VNFs if we can't just run them as pods?
Yeah, so let's talk about it. I mean, we discussed how Kubernetes can be used in the edge cloud as long as there are containers. We talked about some of the problems in deploying VNFs in a Kubernetes cloud. So now let's talk about, so the question is, how do we run VNFs in a Kubernetes edge cloud, right? So if a VNF has to run as a VM, then what we need is a notion of a VM pod, right, in Kubernetes, which can run a virtualized workload. If we have this, it kind of simplifies things a little bit, because Docker pods can run edge applications and also VNFs that are containerized. And we can have VM pods which can run edge applications and VNFs that are virtualized or VM based, right? Also, we need these Docker pods and VM pods to kind of coexist and perhaps even be networked together in a seamless way. So Kubernetes has the container runtime interface, the CRI, and we can have a Kubernetes CRI implementation for running VM workloads. So this is an interesting way of handling VNF. So one way to do this, one way to use the Kubernetes CRI implementation and have and have a VM running, one way to do this is using the open source Vert Lit technology. So that's what is shown in the picture here. It's the same as what we saw a couple of slides ago, but here the Kubernetes Edge Cloud is running edge applications that are containerized and also a bunch of VNFs that are virtualized.
All right, so what is Vert Lit and how does it solve this problem?
All right, so let's talk about Vert Lit. So as I said, Vert Lit is a Kubernetes CRI implementation for running VM workloads. It's really targeted at VM workloads that need to behave like a container on the outside, but inside it's actually a virtual machine. Now, Vert Lit can run unmodified OpenStack VM images using QCOW2 format. And since it's a CRI implementation, the advantage is, all higher level Kubernetes objects can be built using VM pods. Essentially, Kubernetes treats a Vert Lit VM pod just like it treats a Docker pod, for example. All familiar kubectl pod commands still work with Vert Lit VM pods. We can integrate these Vert Lit pods with cluster networking using all the popular CNI plugins, and it's also easy to deploy. Now, let's look at some of the capabilities, right? Vert Lit capabilities in greater detail. I already talked about the cluster networking. Pod IP is used inside the VM, and and VM pods can be targeted by higher level Kubernetes services, just like any other services. TCP and HTTP readiness probes are also supported. With Vert Lit pods, there is support for cloud init also. That means you can add SSH keys to your VMs running in the pod. You can add extra setup scripts, mount raw devices, ephemeral volumes. So it kind of makes it a very powerful concept. And especially these are, Vert Lits are well suited for running VNF workloads because of the powerful networking capabilities. As I already explained, you can run CNI, Genie, multiple interfaces, and various networking options.
Well, I do want to talk more about networking, but before we get there, just really quickly, Vert Lit isn't the only way to do this. I mean, it's the way that we prefer, but it's not the only way to do this, right?
Absolutely, yeah. It's just one way to do it.
Right. Okay. So let's talk more about networking. How do these things? I mean, can they talk to each other? If you got a VM and a Docker container, I mean, how do they talk to each other?
Yes, they can certainly talk to each other. Otherwise, it would not be that useful, right? So let's look at this as shown in this picture. What do we have? We have Docker pods and we have Vert Lit VM pods. They're all networked together in an edge cloud. So here we use CNI Genie for multiple CNI support. If you look at the picture for the VM pod, there are two interfaces. One interface is connected to a flannel network, and the other interface is connected to an SRIOV network for data plane acceleration. this can be used for a VNF workload running requiring high network throughput. Now, the Docker part also has an interface connected to Flannel network, right? So we can easily configure these networks to achieve control plane, data plane, data plane traffic isolation. When you are running VNF workloads, these are some of the key requirements: ability to have multiple network interfaces and each interface connecting to a different network, isolating the control plane or the management plane and the data plane traffic within the NFV environment. So this is what really makes Vert Lit very well suited for running NFV workloads.
Excellent. Yeah, so now when you have all of these edge, all these edge networks and edge nodes all over the world, and you can't just send somebody out to do something, how do you manage all of that?
Right. So we briefly touched on this topic a few slides ago. Management of these distributed edge clouds is a very important topic, and this picture that I'm showing here, it's directly from the Akraino project, and again, Akraino project, for those of you who are not familiar with the project, is a project focused, open source project focused on the edge cloud, and it's gaining a lot of momentum. And here it shows a hierarchical deployment model, hierarchical management model for the edge clouds. So as you can see, there are two central clouds here, C1 and C2. So these central slides, it's not a central cloud central site, a central site that can deploy a collection of regional sites, R1, R2, R3. These are all regional sites. And the idea is the regional sites can actually manage the edge sites, the E sites that are here. And for each region, there is the concept of an edge flock, which is a collection of edge clouds. And the regional manager can actually manage the edge clouds within each edge flock. So that's the idea here. Again, this is one way to do this, one architecture for doing this. Depending on the deployment architecture, there will be many. Talk about just a few of them. We can just have one central region deploying, and managing various edge clouds, if that makes sense for a given deployment architecture. And the other architectures that have been discussed are ability to have very minimal control plane in the edge clouds, and having a more central, having a centralized cloud that manages those clouds. And lastly, the other architecture that comes up is having remote computes, having a centralized control plane and a remote compute. There are a lot of challenges there. Again, these are all various options for management of distributed edge clouds, and how you pick them really depends on the overall deployment architecture and the use cases that you plan to support on the edge clouds.
Okay, and just to be clear here in terms of the scale, so the E dots, the purple dots there, each of those is an individual cloud with its own nodes, and each of those nodes has multiple clients connecting to that.
That is correct. That is correct.
Okay. So we've got a lot of connections going on.
Yeah, absolutely. I mean, think of each E dot here sitting below a cell tower, and multiples of those being managed by a region R, and the multiple regions managed by a central site.
Gotcha. Okay. So we talked about Vert Lit, we mentioned Akraino. What are some of, I mean, there's probably a ton of open source projects that are involved in edge computing at this point.
Right. So here is a small list of key open source projects in the edge cloud area. There are a few more. I think it's driven heavily by AT&T, Intel, Wind River. A bunch of players are involved and more in this project. We had the first summit last month, and there is a network cloud blueprint that's out, and also seed code for the network cloud blueprint from AT&T. And as I said, this project is certainly gaining a lot of momentum. Is another interesting edge cloud open source project. It's an open foundation project, and the edge cloud software stack is based on Wind River Titanium, and Wind River are driving this project heavily. And Starling X could also have a blueprint that goes into the Akraino edge stack. So Akraino project is more of a migration open source project, and that could have blueprints from other upstream projects
For
as
those
well.
of you who are familiar with
ONAP,
OPNFV, this is sort of like the OPNFV of Edge, where they don't really necessarily build the software, they just sort of make sure that all the software that's out there talks to each other.
correct. Right. So then ONAP is another. There is a edge automation. There is a edge project within ONAP on Edge Cloud, and again, ONAP will be a critical component for Edge Cloud because that's where the orchestration. It's the key orchestration component for orchestrating VNF workloads, or maybe even orchestrating edge applications. So ONAP is likely to play a key role there. And OPNFV also has a edge cloud project more focused on the VNFs.
I think we have more projects.
No, there are more projects actually. For example,
okay,
yeah.
Go ahead.
But actually, Google, Google is also Kubernetes. Actually, Kubernetes is a edge related SIG group that has also started up. Now, let's the other interesting thing to look at is the POCs that are under the HC MEC umbrella. So basically, HC MEC ISG, which is a standards body, has a POC framework, and there are quite a few interesting POCs that have either been completed or in progress. This is another interesting thing to look at because it gives us a very clear picture of what some of these key players are focused on in edge computing. I have a bunch of these MEC POC. For example, video user experience optimization. This was done Intel and China Mobile under the MEC POC umbrella. So this is basically looking at video streaming to an edge cloud, and the MEC application is capable of understanding whether the video stream is a paid stream or an unpaid stream, and then optimize the paid stream based on certain criteria. The second one, applications based on the radio link. This was by Telecom Italia. Okay, this is another interesting POC, which is where the MEC application is basically looking at the RAN information, the radio information, and depending on whether the RAN is congested or not, it's kind of adopting the application. So it's kind of like traffic shaping. On the enterprise services side, Adva and Saguna, they were involved in a local breakout. This is users entering the edge, and from the RAN network, there is a local breakout to the enterprise network. And similarly, there can be data prioritization and acceleration. So a MEC application sitting in the edge and looking at the data and maybe L4 to L7 content and prioritizing the data based on the defined criteria. And then quite a few stadium events and healthcare use cases that use the network slicing concept. And then Nokia and Vodafone, they were involved in edge video analytics. And so this is typically the data reduction. In fact, this will become a very important use case because, I mean, this type of use cases and applications, because with 5G, there will be tremendous amount of data getting into the network, and unless the edge clouds either process them or filter them and reduce the data going to the central cloud, the clouds as they are designed today will be able to handle that much of data bombardment. So these type of applications will become really critical. MEC and CDN, a very good use case, because now a lot of the CDN can move to the edge, and user experience, network throughput, latency, all those things apply in these use cases. And then MEC application orchestration with multiple MEC platforms. This is another very good use case because if you think about it, many years down the road, when we have a large number of MEC applications sitting being managed by some kind of an application orchestrator, they are not going to know where exactly they are going to run, which edge cloud they are going to run. So it becomes important for the edge applications and also for the edge clouds to be able to run any application on any cloud, whether it's a Kubernetes-based edge cloud or an OpenStack-based edge cloud or whatever edge cloud. So that kind of compatibility needs to exist. So this POC was along those lines. And then with KDDI and HP, there was a IoT and V2X type of use case. These are also popular use cases.
All right. So that gives us a good idea of some of the things that are actually going on right now in terms of POCs, and things move pretty quickly. So this could give us a good look at what the real landscape is going to be in the next year or two. So that's interesting. All right. So we have reached to the end of our content. We're ready to take some questions. If you go to the next slide, Satish. We would like you to go ahead and submit your questions. While you're doing that, if you would go ahead and feel free to sign up for, if you're interested in Vert Lit or using VMs on Kubernetes, and grab this Vert Lit 101, just to kind of get a feeling of how this works, whether you want to participate in the Vert Lit project or you just want to use it, whatever, we would love to have you. So, as I said, go ahead and throw your questions in the questions pane. In the meantime, let's just kind of go ahead and grab some of the questions that have already been asked. All right, is the low latency characteristic of the edge cloud mainly a function of the cloud being close to the user?
So that's a good question, Nick. So users' proximity to the edge and avoiding multiple network hops is certainly a key component, right, in achieving low latency. However, the edge infrastructure design should also ensure that unnecessary delays are not introduced, especially in the data path, right? So this is where EPA features like NUMA-aware scheduling, CPU pinning, huge pages will help. And the data plane acceleration techniques like SRIOV, DPDK, they also help in accelerating the data planes. This is why this is actually the reason why the edge cloud infrastructure has a lot of commonality with NFVI. It resembles the NFV infrastructure to a great extent. So the answer is yes, proximity is an important component, but the actual network edge infrastructure design also matters.
Okay. Let me go through this list here. How does edge computing work with wireless communications versus satellite communications?
How does edge communication work with wireless versus satellite communication? Actually, it should not matter. I mean, so the way I'm looking at this is, again, I'm not an expert in different access technologies, but from an edge cloud point of view, these are two different access methods, right? So we talk about radio access versus Wi-Fi access, I mean, wireless access, or cable access or fiber access. So it's just another access method purely from an edge cloud point of view. But there could be other factors for that, but I'm not very familiar with those access technologies.
Okay. We do have a few Vert Lit questions. Does Vert Lit solve all the problems that we talked about with VNFs?
Yeah, this is a loaded question. So let's address some of the things. So first of all, Vert Lit is certainly a critical building block, I think, in solving some of the VNF problems we talked about, right? So what does it do? It allows a VM-based VNF to run unmodified in a Kubernetes environment, right? And thanks to the adoption of CNI Genie, Vert Lit supports using multiple interfaces, including, as we said, the SRIOV interface. So SRIOV support is critical to achieve the performance and latency requirements. And as I described, you can have network isolation and all that, right, with Vert Lit. So it's actually a great option, but it doesn't solve all the problems, to answer your question. So for example, let's say we have a complex VNF with multiple components, each running as a separate VM, and let's say a proprietary VNF manager designed for some other VM, let's say OpenStack. It's going to take some effort to adopt this VNF to the Kubernetes Vert Lit environment. Again, I'm describing a problem more on the VNF side, but it does affect the entire ecosystem. Using to use those VNFs with Kubernetes Vert Lits, it's going to take some engineering cycles. But having said that, there will still be many use cases where Vert Lits can be used to design very efficient and small footprint Kubernetes edge clouds. And also the key point to remember here is it's a great transition path, right? As we move towards more and more VNFs becoming containerized and cloud native. So you can start off with a Kubernetes edge cloud, have Vert Lits and run VNFs, and very soon more and more VNFs are going to become containerized and cloud native, and it becomes very easy to transition those to these edge clouds.
Gotcha. Let's stay with Vert Lit for another minute. A VM requires a hypervisor to run on. Where does the hypervisor fit in this scenario of Vert Lit and VNFs? Is it inside the container? I think it's inside the container, isn't it?
Yeah, it's inside the container. That's correct. So it is That's an interesting question. So, so we are going to have a VM, which is essentially a CRI implementation, and it runs a KVM uh, uh, VM. So that within the VM package itself.
Okay, let's.
We can certainly provide a complete, in fact, if you go to the Vert Lit open source website, there is a architecture section and a document that kind of highlights exactly how the implementation works.
Oh, great.
Yeah, we can certainly point to that.
You know what? I will make sure that that is in that Vert Lit 101 document. Which
Yeah. There is a very nice architecture document that actually shows the various components and how it works. And again, as I said, the nice thing here is it is treated exactly like a Docker pod, since it is a CRI implementation and not just a management add-on. So a Vert Lit pod, for all practical purposes, will be treated very similar to a Docker pod. And anything that you can do to a Docker pod, pretty much you can do to a Vert Lit VM pod.
Got it. What is the RAN Enterprise Breakout?
Right. So RAN Enterprise Breakout is a interesting enterprise use case where users joining an edge cloud from their mobile device or any device, they would be directly tunneled and connected to the enterprise. So there could be, instead of going through the cloud. So so basically the breakout or the tunneling gets implemented all the way from the edge to the enterprise network. This can give you a lot of interesting options. For example, there could be security and authorization kind of components running on the edge itself, and so this way, and there could also be intrusion detection, intrusion prevention kind of VNFs running, and it could protect the enterprise networks, make the enterprise networks more secure.
Okay. What is the difference between Vert Lit and KubeVirt?
Right. So this is another interesting question. So basically, we talked about Worklets, and we said that this is one way of doing this. One way of making VMs run in a Kubernetes environment. So KubeVirt is a very different way of doing it. KubeVirt is a virtual machine management add-on for Kubernetes, and it controls VMs as a Kubernetes custom resource. So that's the key difference. So Vert Lit is a CRI implementation, which means Kubernetes will see the VMs, the Vert Lit VMs, exactly the way it sees Docker containers. Whereas with KubeVirt, it's a management add-on. So having said that, both approaches have their is one is more suitable than the other. It's not like one is always better than the other. So with KubeVirt, since it's an add-on, VMs need to be managed separately from kubelet. So which means it's going to require new commands for kubelet, and also it needs a new controller. So in some ways, this is an advantage, right? Because now KubeVirt developers have the freedom to implement whatever they want, as opposed to being limited by the pod definition, right? And at the same time, it also has disadvantages because many parts of the Kubernetes need to be re-implemented. You can end up with a bigger code base, right? So with Vert Lit, on the other hand, so all VMs are defined as very much similar to Kubernetes pods, and they are treated as first-class citizens. So the advantage is that anything you can do with pods in Worklets, you can do with anything you can do with Docker pods, you can pretty much do those with Worklet VMs right out of the box. And the disadvantage here is that you're kind of limited to the functionality that comes with the pods. If you want to do anything fancy, that needs to be implemented separately.
Okay.
Now, having said that, the biggest advantage of Worklet pods is really in networking and especially NFV workloads. And the question is, why is this? Because we talked about CNI, Genie. Worklets actually supports multiple interfaces. Support for SRIOV is there, and support for multiple interfaces, network isolation. So these are all the key factors that make the Worklet pods more powerful. And KubeVirt doesn't have this much of flexibility when it comes to VNFs and networking.
Okay, so we got about 3 minutes left. So let's see if we can get through the rest of these questions. Do you have any thoughts on Envoy and Istio and how that fits into the networking framework of edge cloud networking with Vert Lit? I don't know how familiar you are with Istio.
I'm familiar with the service mesh concepts, and I have to look into how that fits into the edge cloud and the NFV framework that we have been talking about. So essentially, those are offloading some of the general networking functions to sidecars, right? That's kind of the idea there. And for edge cloud, I don't know how it applies. One thing I can think about is if we need to keep the network latencies very low, maybe that's not a problem at all. So in short, I need to look into that, and we'll be happy to
I think that's
get back to that. Yeah.
Okay. What exactly is the MEC application? Who owns it? Who builds it and operates it? Is it defined per the use case?
So MEC application is, MEC is multi-access edge cloud, right? So MEC application is a generic term used for any edge application. I mean, it became popular because most of the MEC POCs came under the Etsy MEC ISG umbrella. Now, who develops them? Who manages them? That's a very interesting question, and this is what is going to evolve, right? As 5G and edge cloud takes over. The dream here is that the Mac applications would become very much like mobile apps that we see on iPhones and Android phones. So think of application developers developing interesting Mac applications, right? Interesting applications, and then service providers would host these applications. So that's very much possible. And then just like the Android market or the iPhone market, you can have these Mac applications have their profiles. An application can say, hey, these are the things I need to run. These are the type of clouds I need to run. I need a VM. I need a container. I need, these are the things I need. And then potentially edge clouds, when they register with the orchestrator, can also publish those kind of profile information. And an intelligent Mac application orchestrator could mix and match those things and figure out, oh, okay, I need to run this Mac application on I can run these Mac applications on these clouds. And
Gotcha.
It becomes even more interesting, Nick, because there could be on-the-fly configuration of these applications. You have.
I'm going to have to interrupt you here because I'm sorry we're at the top of the hour. So I'm going to give you a yes or no. Give me a yes or no on this one. Do these use cases apply to the far edge as well? If so, can a third party create a VNF that runs on a VCPE? Yes or no? Or you don't know?
Yeah.
Okay. Yes, the answer is yes, although it's probably complicated.
Yes.
All right.
Depends is the correct answer.
It depends. There you go. All right. Well, I'm going to hand it back to Sanjeev. And thank you all for joining us. And Sanjeev, it's all yours.
Thank you.
Thank you, Nick and Satish. I think we are right at the top of the hour, so we'll close right away here. Thanks, Nick, for handling the questions, and you made my job easier today. And Satish, that was a great presentation, and I'm sure the audience will be looking forward to getting further information from the links you provided. Thank you all. We look forward to
helping us too. Sorry. Go ahead.
Thank you, Sanjeev, and thank you very much.
Sure. And we look forward to having you all on a future CNCF webinar. And please look for the links that will be sent to you. Thank you. Have a good day.